Okay, let's dive into this. Welcome to today's Explainer, where we are going to unpack a truly mind-bending technical white paper called Hybrid AI-Driven Video Streaming, or AIVS for short. Look, we stream videos every single day, right? And honestly, it feels like magic. You tap a thumbnail and boom, high-definition content instantly beams right to your screen. But behind that seemingly flawless, effortless experience, the underlying infrastructure is actually being pushed to its absolute breaking point. So today, we're looking at a proposed architectural shift that completely reimagines how video data moves across the globe.
Now, I really want you to think about that for a second. We are so incredibly accustomed to the idea of downloading or streaming a file frame by frame, pixel by pixel. But what if the next time you hit play, you aren't actually receiving a video stream in the traditional sense? What if instead, your device is quietly receiving a set of instructions and your phone is literally generating the video right in front of your eyes, in real time? I know it sounds straight out of a science fiction movie, but as this white paper outlines, it is very much the imminent future of streaming. And this right here is exactly why this shift is so urgently needed. 80%. According to the HAIVS architecture, that is the massive amount of user data we are currently wasting. When you really start looking at the hidden stakes of our daily streaming habits, the sheer inefficiency of how we currently move pixels from a remote server to your smartphone is just staggering. We're chewing through massive amounts of data simply because we're relying on a decades-old brute force method to deliver content. Which leads us straight into our first section, the hidden streaming crisis and the skyrocketing cost of this pre-rendered storage model. See, while streaming feels perfectly solved to you and me on the user end, the server-side infrastructure is completely trapped in a massive, totally unsustainable storage crisis. And it's all driven by this pre-rendered storage model. Let's play a quick guessing game here. When a creator uploads a single video to YouTube, how many transcoded versions of that exact same video do you think the platform has to create and store on its servers just to ensure everyone everywhere can watch it? Take a guess. Maybe 3? 5? No way. It's actually 10 plus. They have to store more than 10 versions of every single video. They've got to keep to 144p version, the 240p, the 480p, all the way up through 1080p, 1440p, and 4K 2160p. Now, multiply that massive redundancy by billions of videos, and you are looking at literal exabyte-scale storage bloat. The server-side compute costs to encode and hold all of these redundant files are absolutely astronomical. Now, what's really interesting about this slide is how this bloat spirals into much bigger, very real-world problems. First off, there is a massive environmental toll. Just cooling and powering the hardware required to store all these redundant datasets significantly increases a company's carbon footprint. But honestly, even more critically, there's a huge humanitarian and accessibility limit. In emerging markets where high latency 2G or 3G networks are still the norm, this bandwidth barrier literally blocks people from high-definition streaming. If you don't have the pipe to push heavy 4K pixels through, you're stuck with a terrible, heavily pixelated experience. So the whole system is bloated, it's insanely expensive, and it's leaving people behind. And this is exactly where the HIVS architecture steps in. All right, section 2, let's look at this new paradigm, hybrid AI-driven video streaming. HAIVS is a total paradigm shift designed to shatter that bottleneck. And it does it by utilizing the massive AI processing power that's literally sitting in your pocket right now, specifically leveraging Android devices and the Gemini Nano runtime. To really grasp this, think of it like this. The old way, pixel streaming, is essentially like a bakery trying to ship you a heavy, fully baked multi-tier cake. It requires massive packaging, it's super expensive to ship, and if traffic is bad, meaning you have low bandwidth, it arrives completely ruined. Neural-Reconstruction changes the entire game. Instead of shipping you the heavy cake, the server just ships you a super lightweight visual recipe and the base ingredients. Your phone steps up, acts as the chef, and actually bakes the cake locally, right on your screen. The absolute secret ingredient that makes this all possible is something called the Neural Style Map, or an NMP file. Instead of downloading heavy, pre-rendered pixels, this incredibly lightweight file contains the mathematical parameters of the video. We're talking key textures, lighting data, and object definitions. It's the ultimate blueprint that allows your phone's AI to reconstruct the high-definition video locally. Let's move to and see how this builds into section 3, how neural reconstruction works using the capacitor neural model. This capacitor neural model is the exact technical blueprint of how this magic trick is pulled off without you ever noticing even a millisecond of delay. It happens in 3 rapid-fire phases. Phase 1, to give you that instant zero-latency playback when you hit play, the server fires a capacitor burst. This is just 10 seconds of traditional standard HD video. While you're happily watching those first 10 seconds, Phase 2 kicks in quietly behind the scenes, the metadata handshake. This is where the server slips your phone that lightweight neural style map. Then we hit Phase 3, and this is the real magic. The server suddenly drops the video feed way down to a tiny ultra-low bitrate 240p skeleton stream. Your local Gemini Nano AI grabs that blurry 240p skeleton, applies the visual recipe, and synthesizes a flawless 4K image in real time. You are literally watching 4K, but you're only downloading 240p. Mind-blowing, right? Of course, pulling this off requires some serious network magic. The infrastructure relies on Google Global Cache to park these neural metadata packets at the edge, essentially right in your local neighborhood, so they arrive even faster than the video itself. They also use the Quick protocol to completely minimize any lag during that handshake. And brilliantly, it uses Redis-based orchestration to actually look at your specific phone, calculate your neural processing unit's exact processing power, its T-flops, and then it sends a metadata packet that is perfectly optimized for your hardware. Which naturally brings up a pretty major concern regarding your device. That brings us to Section 4, optimizing your Android device and the role of the resource governor. Because I know exactly what you're thinking. If my phone is constantly synthesizing 4K video using AI, isn't it going to overheat and drain my battery in like 10 minutes? Well, the authors of the HAIVS paper anticipated exactly that. Enter the resource governor, which is a deep integration straight into the Android OS kernel, designed specifically to manage this massive AI workload. So the crucial point is how this system protects your hardware. When you go full screen on a video, Android initiates intelligent process hibernation. It literally freezes non-critical background apps to free up resources. Then it uses priority mapping, locking your AI chips, your NPU, into high-performance mode while putting your standard power-hungry CPU cores into a deep sleep. And hey, if things do get too hot, say your phone hits 40 degrees Celsius, adaptive fidelity kicks in. It seamlessly aborts the AI reconstruction and just switches you right back to traditional server-side streaming until the device cools down. Playback stays seamless, and your hardware is totally protected. Let's wrap up the technical deep dive with Section 5, security and real-world impact. Because we really have to ask, what happens when we start letting local AI essentially generate the content we're watching? There are very real cybersecurity threats here. If the AI on your phone is reconstructing the image, what stops some bad actor from intercepting the instructions and injecting a deepfake? Or what stops the AI from simply hallucinating and casually adding things to the video that the original creator never even put there? Well, the architecture solves this with 2 really distinct protocols. First up is Neural DRM. That neural style map is heavily encrypted with a temporary session key, meaning third-party models absolutely cannot intercept or hijack the visual recipe. Second, to prevent those AI hallucinations, they use frame hashing. The server essentially sends over a mathematical fingerprint of what the true frame should look like. As your phone reconstructs the image, it's constantly verifying its work against the server's checksum in real time, guaranteeing absolute content integrity. And this brilliantly illustrates why all this incredibly complex engineering is worth it. Just look at the return on investment here. Storage drops from that massive 10+ version redundancy down to minimal, just one base file and the metadata. The data cost to you, the user, drops off an absolute cliff. Instead of downloading 100 megabytes for a 1080p video, you're downloading just 15 megabytes. Server load plummets. And most importantly, global reach completely flips. Instead of being dependent on a country's physical bandwidth infrastructure, it simply becomes dependent on the power of the user's device. We are talking about bringing flawless 4K to the entire globe. And guys, this isn't just theory. The white paper outlines immediate next steps. They're already initiating pilot programs specifically testing this on current hardware like the Pixel 8 and 9 series using Gemini Nano. They're actively working to standardize that .nm file as a global open-source format. And eventually, the plan is a phased decommissioning of all that bloated legacy storage, wiping those redundant 480p and 720p files off the servers forever. It really comes down to this incredibly powerful summary directly from the paper itself. The HAIVS architecture transforms the smartphone from a passive receiver into an active participant in the streaming ecosystem. We are fundamentally changing the relationship between our devices and the internet itself. Your phone is no longer just a dumb screen, it is a real-time rendering engine. By leveraging this on-device AI, we are quite literally compressing the internet. If our phones can take a blurry 240p skeleton and intuitively rebuild a flawless 4K movie right in the palm of our hands today, it really begs the question, what impossible technology is your phone's AI going to rebuild next? Thanks so much for joining me on this explainer, and I will catch you on the next one.